Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to show you how we can start writing SQL using the MySQL workbench. So sit back, relax, and enjoy the show. All right, let's get started, everybody. SQL, it's an acronym meaning Structured Query Language. SQL is used to create, retrieve, update, and delete data from a database. Suppose we own a business, like the Krusty Krab from SpongeBob. If we had to manually track all of the transactions by pen and paper, well, that would be a lot of extra work. If we had a database, we could keep track of these records electronically and save ourselves a lot of trouble, right? There's two types of databases I'll discuss: relational and non-relational. A table in a relational database, it resembles an Excel spreadsheet. There's rows and columns. Tables within a relational database can form, well, relationships with one another. And that is done by this concept of keys, which I'll explain in a further topic. Then there's non-relational databases. That's where our data is organized in any format but a table. This could include JSON files, key value pairs, graph data structures, entities of that nature. To utilize data in a relational database, we would use SQL. Then with a non-relational database, we would use a different language named NoSQL, meaning not only SQL. But since this is an SQL series, we will be working with SQL and relational databases, not non-relational databases. To write SQL statements, we would need the help of a special piece of software known as a database management system. People shorten this to simply DBMS. It's a workspace for us to write SQL statements and generally just work with our database. It'll make our lives easier. There are different DBMS systems you can use, one of which is MySQL, Microsoft SQL Server, Oracle, and PostgreSQL, but there's still many more out there. Each of these database management systems all use SQL, but there's subtle nuances between the syntax of each database management system. If you're familiar with one database management system, transitioning to another will take little to no effort at all. In this series, we will be working with the MySQL database management system, and I'll show you how to download that for both Windows and Mac OS. Hey everybody, in this topic, I'm going to explain how we can download MySQL using the Windows operating system. First of all, head to this website, mysql.com, then go to the Downloads tab. Scroll down, look for MySQL Community Downloads. We'll click on that. Click on MySQL Installer for Windows. Make sure that we have our Windows operating system selected. Then download the first installer. No thanks, just start my download. We will open this download once it's complete. There are various setup types depending on what packages you need. For this series, all we need is the server and the workbench. We'll select the custom radio button, click next. We will need the most recent MySQL server. Add that to products to be installed. Open applications, go to MySQL workbench. We will add the most recent workbench. We can close out of that. There is a shell if you're interested in using that, but I will be sticking with the workbench in this series. Once we have our server and our workbench, I will click next, then execute. Looks like there's an error downloading the workbench. I'm going to try again. And it worked this time for some reason. Let's click next, execute, give it some time. Once the installation status for the server and the workbench is complete, we can click on next, next. I'll keep these default configurations. Next. Use strong password encryption for authentication. Let's click next. Here we're going to set the root password to access the server. Think of some password you would like. I'm just going to set mine to be password. I'll keep it simple. Yeah, of course the password strength is weak. You can add user accounts, but that'll be outside the scope of this series. Click next. You can start the MySQL server at system startup if you would like. I'll keep that on. Click next. Then execute. Then finish. then next. Yeah, we might as well start the MySQL Workbench after setup. If this window doesn't pop up, you can easily just search for it. Just look for MySQL Workbench. Now we should have a local instance. We can click on this to access our server. Let's pretend that this wasn't here. I'm going to right-click, delete connection. If you need to set up a connection, hit this plus button. We'll need a connection name. I'll name this local host. Connection method should be standard TCP IP. The host name is 127.0.0.1 at port 3306. Then press OK. So now that we have our connection set up, we can click on it, type in the password you set for the server. Mine was simply password. You can save the password if you want. I might as well. Then OK. And here we are within the MySQL Workbench. All right, everybody. In this topic, I'm going to explain how we can download MySQL using the Mac operating system. First, head to this URL, mysql.com. We will go to the Downloads tab. Scroll down, look for MySQL Community Downloads. We'll need both the server and the workbench, but let's start with the server. Click on this file. Mac OS 12 DMG archive. Click the download button. Click on this link. No thanks, just start my download. When this DMG archive is finished downloading, we can double click on it. Just give it a second. Double click on the DMG archive. Allow. Click Continue. You can read the license agreement. I'm going to pretend I did. Hit Continue. Install. Type in your computer's password if this prompt comes up. Use strong password encryption, hit Next. Then we'll need a password for our server. Type in whatever password you would like. To keep it simple for this lesson, I'm just going to set my password to be, well, password. By checking this box, MySQL Server will start once the installation is complete. You might as well keep this checked, but for demonstration purposes, I'm going to show you how to start the server manually. Then close. I'll go ahead and move the installer to the trash bin. We have the server downloaded. Next, we need to download the workbench. Again, head to mysql.com. Go to Downloads. Scroll down to MySQL Community Downloads. Click on MySQL Workbench. Then hit the blue download button. No thanks, just start my download. Then we can double click on this DMG archive when it's finished downloading. So double click. Drag and drop the workbench icon into your applications folder. Before we access the workbench, let's be sure that the MySQL server is running. Click on the top left Apple logo. Go to System Preferences. At the bottom left corner, look for MySQL. Click on it. Then start MySQL Server, if it's not started already. And you can check this checkbox so that your computer starts up with it running. Alright, you may need to type in your password. The server is now running. To run the workbench, we can go to Finder, then Applications, look for the MySQL Workbench icon, double click on it, and here we are within the MySQL Workbench. To access the server, you can click on this local instance connection, then type in the password that you originally set for the server. But if you're missing this connection, you can hit the plus button. Then create a new connection name. I'll name this localhost. Use standard TCP IP for the connection method. Hostname should be 127.0.0.1 and port 3306. Then press OK. But I already have my connection set up. Click on your connection, type in the password you set for the server. Then press OK. And here we are within MySQL Workbench. Hey everybody, in this topic, I'm going to show you how we can create, alter, and drop a database. What is a database exactly? Think of it as a folder. It acts as a container. Tables, on the other hand, would be the files found within the folder. In this topic, I'm going to show you how we can create the database itself, but we won't be working with any tables until the next topic. We'll need to begin by heading to our query window, which is this large window right here. We're going to write a statement. To create a database, we will type create. There is no case sensitivity in MySQL. These keywords, such as create, they can be all uppercase, just the first letter could be capital, or you could do all lowercase. With the keywords, I like to make them all uppercase, but that's just me. Create database, and then we'll need a unique database name. What about MyDB? Then it's important with all SQL statements to end each statement with a semicolon. It's like the period at the end of a sentence. That's how we know that the statement is complete. So you'll need these three words: create, database, then a database name. We just named our database MyDB. Hit this lightning bolt button to execute this statement. And in my output window, unfortunately I can't increase the font size, but I can zoom in. This action was successful. We have created database MyDB. If you head to your schemas tab, then hit the refresh button, you should see a database in here named MyDB. There's also a database for sys. Sys is the internal database that MySQL uses. We'll want to be sure that we're using the database that we just created. To use a database, we can either right-click on the database, then click on Set as Default Schema, or you could use a statement. Use, then the name of the database, MyDB, semicolon. Execute this statement. We are now using my database. To drop a database, type drop database, then the name of the database. And our database is gone. Unfortunately, we do need a database for this series, so let's go ahead and recreate our database. Create database MyDB. Refresh. Then just to be sure we're using this database, we can either use that keyword use, or you can right click on the database and set as default schema. All right, so we can create, use, and drop a database. How about alter? There's two features for beginners I'll mention: setting a database to read only. The other is enabling encryption. Let's set our database to be read only. Type alter database, the name of the database, read only equals 1. This statement would make our database read only. If a database is in read only mode, we can't make any modifications to it, but we can still access the data within. Let's attempt to drop our database. Drop database MyDB. Then we have a red X right here. That means we could not complete this action. Drop database MyDB. Schema MyDB is in read-only mode. To disable read-only mode, you would set read-only equal to 0. Now we would be able to drop this database. All right, everybody, that is how to create, use, drop, and alter a database. Think of a database as just a folder. A folder can hold files. The files will be the tables that we'll create, which we'll store within the database. And in the next topic, I'll show you how we can create some tables. Hey, welcome back everybody. In this video, I'm going to show you how we can make some tables in MySQL. A table in a relational database, they consist of rows and columns, kind of like an Excel spreadsheet. In this topic, we're going to create the table and the columns, but we'll be populating the rows in the next video. To create a table, you'll type create table, then the name of the table. I'll create a table named employees. Then add a set of parentheses, semicolon at the end. Within the set of parentheses, we will list the columns. For employees, let's have an employee ID, comma. Each column is separated with a comma. Then a first name, last name. How about hourly pay? That'd be good. Hire date. Which date were they hired? There's one thing that's missing. After each column, we need to set the data type of what we're storing within each column exactly. Is the data going to be whole integers, decimals, text, a timestamp? Those are data types. An employee ID, that could be a whole integer. The data type will be int, add int after the column name. A first name, that's a series of characters. The data type for some text would be var char, then within parentheses, the maximum amount of characters. I think 50 characters is enough for a first name. Last name, var char, 50 is good. Hourly pay. Maybe our hourly pay is in dollars and cents. We'll need a decimal portion. There is a data type. That is decimal. Add a set of parentheses. We'll add the maximum amount of digits for our decimal. I think 5 should be good. Then a precision. 2 for 2 decimal places. The reason that I set the maximum digits of my hourly pay to be 5 is that I don't anticipate anybody's hourly pay being over $999.99 per hour. That's pretty absurd. I think 5 is enough. Then we have hire date. There is a data type, which is date, if you need to work with dates. Otherwise, there's date time if you need to include the time. Just the date is fine. Let's execute this script. We have created our table employees. If I were to refresh my schemas window, underneath tables, we have our employees table. Now I'll show you how we can select a table. If you need to select your table, you can type select asterisk from the name of the table. Employees. Let's take a look. Here's our table so far. There's no rows, but there are columns. We have employee ID, first name, last name, hourly pay, and hire date. If you need to rename a table, you can type rename, table, the original name, employees, to whatever the new name is. Perhaps workers. Let's try that. Rename table employees to workers was successful. If I refresh my schemas window, the table employees is now known as workers. But I think that's stupid. Let's go back and change it. Rename table workers to employees. To drop a table, I discussed this earlier, you would type drop table, the name of the table. I don't want to drop this, so I'm not going to execute this statement, but that's how you would drop a table. Drop table, the name of the table. If you need to alter a table, there is the alter keyword. Let's add a phone number. Alter table employees. I'm going to write this next part of the statement on a new line. What do we want to add? What about a phone number? Add phone number. Then we'll need to list the data type of this column. Varchar is good. Max size of 15 characters. Then we will end this statement. Execute the script. All right, we have altered our table. Let's take a look at our table. Select asterisk. Asterisk means all. I don't know if I explained that. Select all from employees. We have employee ID, first name, last name, hourly pay, hire date, then our column phone number. Let's rename phone number and change it to something else. We will again use the alter keyword. Alter table employees. Rename column phone number to, let's say, email. Okay, then let's take a look again. Select all from employees. Yeah, employee ID, first name, last name, hourly pay, hire date, then email. However, the data type has not changed for email. I'm going to refresh my schemas, then underneath information, underneath employees, our email column has a max size of 15 characters. Let's change that. Alter, table, employees, modify, column, email, then the new data type. Varchar, maybe 100 characters for an email. Let's execute this statement. Refresh our schemas. Yeah, now our email column has a size of 100 characters. Maybe we need to change the position of our email column. If you need to move columns around, this is how you can do so. Let's move our email column so it's after our last name column. To do that, we would type alter table, the name of the table, modify, the name of the column to be moved, email in this case, then the data type. This email column has a data type of varchar 100. Then the name of the column we would like our email column to follow. I need my email column to come after my last name column. I will type after last name. Then afterwards, I might as well just display everything. Select all from employees. You can write more than one SQL statement. Here we are, employee ID, first name, last name, email, hourly pay, hire date. If you're modifying a column and need it to be first, you could just say first. Email, employee ID, first name, last name, hourly pay, hire date. You can use the after keyword, then a column, or first if you need the column to be first. Now to drop a column, you would type alter, table, employees, drop, column, the name of the column to be dropped, email. Our email column is no longer there. All right, everybody, that's how we can create a table and work with the columns. In the next video, we're either going to talk about data types or learn about inserting rows into our tables. I haven't decided yet, but we'll probably cover one of those too. Hey everybody, in this topic, I'm going to show you how we can insert rows into a table. We have a table named employees. I will select everything from my table, employees. Here are the columns. We have an employee ID, first name, last name, hourly pay, and hire date. To insert a row into a table, we would type insert into the name of the table, followed by values, parentheses, semicolon. Between this set of parentheses, we will add all of the data for a row. We will follow this order, beginning with employee ID, first name, last name, so on and so forth. But we do have to pay attention to the data types too. Each piece of data will be separated with a comma. Let's begin with an employee ID. The first employee will be Mr. Krabs. He's the first employee. I'll give him an employee ID of 1. Then we'll need a first name. I'll put that within quotes because the data type of our first name is varchar. Basically speaking, that's text. Mr. Krabs' first name is Eugene, according to SpongeBob lore. Then we have a last name. Last name Krabs. Hourly pay. This is a decimal. Mr. Krabs' hourly pay will be $25.50. I'm just making up numbers here. Hire date. Here's the format for a date. Within a set of quotes, we will list the year, followed by the month, then the day. I'll set Mr. Krabs' hire date to be January 2nd, 2023. Now we can execute these statements. Yeah, here we go. Here's the first row. Employee ID 1, first name Eugene, last name Krabs, hourly pay $25.50, hire date January 2nd, 2023. It can be somewhat tedious to manually insert each row, one statement at a time. Let's insert multiple rows at once. To do that, after my set of parentheses, I will add another set of parentheses, each separated with a comma, depending on how many rows I would like to enter. So I have 4 employees I would like to enter. I will add 4 sets of parentheses, each separated with a comma. And let me just do some formatting to make this look pretty. Each set of parentheses corresponds to a new row. So let's enter all the data that we'll need for this table. Employee ID number 2 will be Squidward Tentacles. Squidward's hourly pay will be maybe a solid $15. Squidward's hire date, the year 2023, January. I think January 3rd is good. All right, so that is the next row. Let's work on employee number 3. Employee number 3 will be SpongeBob. Last name will be SquarePants. SpongeBob's hourly pay will be $12.50. SpongeBob's hire date is the year 2023, January 4th. Employee 4 will be Patrick Star. Patrick's hourly pay will be $12.50 as well. Hire date 2023, January 5th. Okay, last employee. Employee ID number 5. First name Sandy. Last name Cheeks. Sandy's hourly pay will be $17.25. She'll be an assistant manager. Sandy's start date will be the year 2023, January 6th. We can execute this statement to insert multiple rows all at once. Yep, here's our table. We have 5 rows, each corresponding to a different employee. We have Mr. Krabs, Squidward, SpongeBob, Patrick, and Sandy. I'm going to demonstrate what happens when we attempt to insert a row with missing data. I will insert employee number 6. Their first name is Sheldon. Last name Plankton. But we will not insert an hourly rate of pay or a hire date. Here's what will happen. So we have an error. Column count doesn't match the value at count at row 1. We're missing data for our hourly pay and hire date. You could insert just select columns. That is done by adding after the name of the table, add a set of parentheses, then name the columns you would like to insert data into. All we're adding is an employee ID, first name, then last name. Okay, now we've inserted a new employee, but there is data missing, and that's okay. We plan on hiring Mr. Plankton, but we have not yet negotiated an hourly pay or a start date. We still need to run a background check on him, but we want to add him to the system at least. So if you ever need to insert data into a row, but you need to omit certain columns, you can simply just list the name of the columns you would like to insert data into. All right, everybody, that is how to insert rows into a table in MySQL. Hey everybody, in this video I'm going to show you how we can select data from a table. To query all of the data from a table, we would type select asterisk, meaning all, from the name of the table. In my case, we have table employees. This statement, select all from employees, will give me all columns and all rows. But sometimes you may not want all of the data. Here's a scenario. Your boss gives you a task of retrieving the full name of every employee. Well, we don't need employee ID, hourly pay, or hire date for that, right? We just need a list of the first and last names of our employees table. In place of the asterisk, meaning all, we can select specific columns, such as first name and last name. We have all of the first and last names from our employees table. You can change up the order of the columns too. This time I would like last name, then first name. With our query, this returned all of the last and first names of all the employees. Point being, you can select specific columns depending on what you're looking for, or everything with the asterisk. There is a clause known as the where clause. If we're looking for something specific, let's add where. Then what are we looking for exactly? We can write some criteria. let's select all from employees where employee ID equals 1. Then end your statement with a semicolon. This will give us a specific employee, the employee that has an ID of 1. If I set employee ID to be 2, that would give us Squidward. 3 would be SpongeBob. 4, Patrick. I think you get the idea. Here's an exercise. Let's find all the data from employees where the first name equals SpongeBob, where first name equals SpongeBob. This query will return employee ID 3, the first name, last name, hourly pay, and hire date. Here's another example. Let's find all employees that have an hourly pay greater than or equal to 15. Our criteria will be where hourly pay is greater than, we'll use the greater than operator, or equal to 15. This returns 3 employees, Mr. Krabs, Squidward, and Sandy. All 3 of them have an hourly pay of $15 per hour or greater. It is possible your query can return multiple results. Let's find anybody that has a hire date less than or equal to perhaps the year 2023, January 3rd. This query returns 2 results, Eugene Krabs and Squidward Tentacles. They both match this criteria. And in this case, we use the less than or equals to operator. Another operator you should know about is the not comparison operator. It's an exclamation point and an equal sign. We will check if something is not equal. Let's find where employee ID does not equal 1. Who are all the employees that have an ID not equal to 1? That gives us Squidward, SpongeBob, Patrick, Sandy, and Plankton. On the other hand, if I set this to 1, that would give us Mr. Krabs. That is the not comparison operator, if you need to check if something is not equal. In this next example, let's pretend that we're human resources. We need to find any employees that do not have a hire date, and then begin the paperwork for them. Currently, Plankton's hourly pay and hire date are both set to null. Null meaning no value. In place of saying, hire date equals null, in place of using the equal sign, we would type is. Select all from employees where hire date is null. That would return Sheldon Plankton, because his hire date is null. Not equals null, that doesn't work. It would be is null. You could even say is not null. That would return every employee that does have a hire date. All right, everybody, so that is how to query data from a table. Select whatever you're looking for. It can be everything or specific columns from a table of your choosing where the results equal some criteria that you set. It really depends on what you're looking for. And that is how to query data from a table. Hey everybody, in this video I'm going to show you how we can update and delete data from a table. In my example, we have a table of employees. However, Sheldon Plankton is missing some information, an hourly pay and a hire date. Let's update those fields. To update some data in a table, we would use the update keyword, the name of the table, employees in my example, then set. Which column would we like to interact with first? Let's interact with hourly pay. Set hourly pay. Let's pay Plankton $10.25 per hour. We should probably add a where clause. I need to specifically select Plankton. Where? Let's select his employee ID. Where employee ID equals 6. Then semicolon to end the statement. You could also select Plankton by his first name or last name as well. When I execute the script, Plankton's hourly pay is now $10.25 per hour. To update multiple columns, you can change more than one field at once. After your first change, you can add a comma Then change another field. Let's change Plankton's hire date to be the following. Hire date equals 1023-0-07. I'll make his hourly pay $10.50. I'm feeling generous. Here we are. Plankton's hourly pay is now $10.50. His hire date is January 7th, 2023. To set a field to null, meaning no value, you would just say equals null. For example, let's take Plankton's hire date, set the hire date equal to null. Plankton's hire date is now null. So maybe we're going to fire him or something. In this next example, I'll give you a demonstration, but you don't want to follow along. To update all of the rows within a column, you would exclude the where clause. If I were to set hourly pay equal to 1025, that would affect all of the rows. After executing this statement, the hourly pay for everybody is now 1025. That's an example of how you could set a column to be one consistent value. To delete a row from a table, you would type delete from the name of the table. Now don't write just the statement. It will delete all rows in your table. Here's an example. Do not do this. I will delete from employees. There, my whole table is gone. Do not do this. Be sure to add a where clause when deleting from a table. Otherwise, this will delete all your rows. Where employee ID equals 6. Yep, and Plankton is no longer there. All right, everybody, that is a super quick video on how to update and delete data from a table. Hey, everybody, in this topic, I'm going to explain auto commit, commit, and rollback. Auto commit is a mode. By default, auto commit is set to on. Whenever you execute a transaction within MySQL, that transaction is saved. What if we were to make a transaction and we need to undo that transaction? For example, what if we accidentally delete all of the rows of this table? Don't do what I do, but I'll give you a demonstration. I accidentally type in delete from employees, but I forget to add a where clause. Well, all my rows are now gone. How do I undo these changes? Well, what we're going to do is set auto commit to equal off. With this setting set to off, our transactions will not save automatically. We would need to manually save each transaction. It creates a save point, so to say. I'm going to create a save point by typing commit, then execute. Now I'm going to select my table, select all from the name of my table. Then I'm going to go ahead and delete all the rows. Delete from employees. Oh shoot, but I forgot to add a where clause. My whole table is gone now. Luckily, we created a save point with that commit statement. To undo these changes, I can execute the rollback statement. This will restore my current transaction back to the previous save point, where we used commit. Now, if I were to select all from the name of my table, our table is back to what it previously was. And again, to save any changes, let's say I delete my whole table again, delete from employees. If I want to save this change, I would commit. Then again, I will select my table. And that last change is now saved. My whole table is gone. So yeah, that is auto commit, commit, and rollback. By default, auto commit is set to be on. Any transactions after executing are saved. If that mode is set to off, you can commit any changes manually. To undo any changes, use that rollback statement. So yeah, that is auto commit, commit, and rollback in MySQL. Hey everybody, in this topic I have a super quick video on getting the current date and time in MySQL. Let's create a temporary table. At the end of this topic, we'll delete it. Create table. I'll name this table test. We will have 3 columns. the current date, I'll name the column my date. The data type is date. My time, the data type is time. Then we'll combine both. My date time, the data type is date time. Let's create this table. It was created successfully. Then I will select all from our table test. We have 3 columns, a date, a time, and a date time, which combines both. So how do we get the current date? Maybe we need to create a timestamp of when some event happened. Maybe a hire date for our employees. So I'm going to insert into the name of my table, test, some values. For the current date, there's a built-in function, current underscore date, then add a set of parentheses. This function will return the current date. For the current time, there is a current time function. Add a set of parentheses to the end of that function. For the date time, you could just say now, then add a set of parentheses. After inserting this row, let's select all from our table test. Here's the current date of me filming this video. October 21st, 2022. The time is 7 in the morning. The current date time is October 21st, 2022, 7 in the morning. A date time would probably be good for some sort of transaction you need to record. For the time being, I'm going to set the current time to be null, as well as the date time to be null. Now, if you were to take your current date, then add +1, this part of my statement would refer to tomorrow, October 22nd. If you were to take your current date -1, that would technically be yesterday, October 20th. You could do something similar with your time and date time. You can add or subtract seconds, but I think that's pretty self-explanatory. We don't need this test table anymore, so we can delete it. Drop table test. And it's gone. All right, everybody, so that was a super quick topic, but I thought I needed to cover it. That is how to get the current date, time, and date time in MySQL. Hey everybody, I have a quick video on the unique constraint. The unique constraint ensures that all values in a column are all different. That's basically it. We can add this constraint when we create a table or after. Let's create a new table. Create table. Let's create a table of products. What products do we offer? We'll list the columns. Let's add a product ID. The data type will be int. Product name. The data type will be varchar, maybe 25 characters. Then a price. Price. The data type will be decimal. Our price will have a max size of 4 digits and a precision of 2 decimal places. To add the unique constraint, select a column. After the data type, add the keyword unique. And that's all you have to do. With this keyword unique, we can't insert any product names that are the same. They all have to be, well, unique. Let's create this table. Let's say that you forget the unique keyword. Then you create the table. What you could do instead is type alter table, the name of the table, products, which we just created, add constraint unique, the name of the column within parentheses, product name. If you forget to add a unique constraint to a column after you already create the table, this is what you can write. However, when I run this, I do have a warning. I already have a unique constraint on that column. But yeah, that's how you would add a unique constraint to a column in a table you have already created. Let's select our table. Select all from products. We have a product ID column, product name, and a price. Let's insert all of our values. Insert into the name of our table, which is products, values. We'll insert maybe 4 rows. We'll need a product ID, name, then a price. For a product name, we have a hamburger, and the product ID, I'm just making up a number, is 100. The name is hamburger. The price will be $3.99. Fries will be our next item. Then we have fries. The price will be $1.89. 102 will be soda. The price is $1 even. 103 will be ice cream. The price will be $1.49. Let's test the unique constraint that we have added to the product name column. Suppose that I forget that I have fries on the menu already, and I will add another row. 104 fries, 189. Actually, let me change the price to maybe something different, like 175. Here's what happens when I attempt to add two values that are the same. Duplicate entry fries for key products.product name. MySQL is telling us that we have a duplicate under the product name column. We have fries twice. Since we added the unique constraint, all values in this column must be different. If I were to remove the last column where we have that duplicate, well, then this would run just fine. Now let's select everything from products. Yeah, there we go. Here are the products. We have a hamburger, fries, soda, and ice cream all on the menu. So yeah, that's the unique constraint. You can add that constraint when you create a table or after. Whatever column has that unique constraint, all the values need to be different. So yeah, that's the unique constraint in MySQL. Hey everybody, in this topic I'm going to explain the not null constraint. The not null constraint can be added to a column when you create a table. Whenever we enter a new row, the value within that column can't be null. For example, I have table products. We have a hamburger, fries, soda, ice cream. If I were to recreate this table, I would type something like this. Create table products. I would list the columns. We have product ID. The data type is integer. Product name. The data type is varchar. I believe I set this to be 25 last time. Then price. That is a decimal. We gave this column a max size of 4 digits and a precision of 2. Any column that I do not want to have null values, I will simply just add not null. This is a constraint. Now I've already created this table, so I'm not going to execute this statement, but that's how you would create a table that has the not null constraint. After the column name, you just type not null. To add the not null constraint to a table that already exists, you would instead type alter table, the name of the table, modify the name of the column, the data type of the column, in this case decimal, 4, 2, then not null. It's a little bit different than the unique constraint in the last topic. So let's execute this statement. That seemed to work. Let's add a new item to the menu. I will select everything from my products table. Select from products. Let's add a new item to the menu. And we will test that not null constraint. Insert into products values. We have 104. Product ID 104 will be, how about a cookie? I'm not going to set a price. I will say null for the price. Maybe I'm not decided on what the price is yet. After executing this statement, well, we have an error. Column price cannot be null. Since we set that not null constraint on the product price, we can't enter a null value. We could set this to be 0. That's acceptable, but it can't be null. So yeah, everybody, that's the not null constraint. It's a useful constraint to verify input. If there's any column that you don't want to have any null values, just add that constraint. And yeah, that is the not null constraint in MySQL. Hey everybody, in this topic I'm going to explain the check constraint. The check constraint is used to limit what values can be placed in a column. For example, I live in the United States. Depending on which state you live in, there is a minimum hourly wage that employers have to pay. In this example, let's set an hourly pay to our employees table. Every employee needs to be paid at least the minimum wage in that region. And we can do that with the check constraint. We have our table of employees. If I were to recreate this table, it would look like this. I think that was pretty close. To add a check to a column at the end of our table, this is what we would write. Check, then within parentheses, what sort of condition do we want? Let's check to see if our hourly pay column is greater than or equal to maybe $10 per hour. That will be the minimum wage in this region. This would work if we were to create this table. However, it's typically a good idea to give your check a name. Just in case you need to drop it later, you can easily identify it. So precede check with constraint, then a constraint name. What about CHK, meaning check, underscore hourly pay. This check will be known as check hourly pay, so we can identify it. Then we can drop it or make any changes to it if we need to. I do already have an employees table, so I'm not going to execute this statement. But to add a check constraint to a table, you would just add a row like this to the bottom. If you instead need to add a check constraint to a table that already exists, this would be the syntax. Alter table, the name of the table, add constraint. Then we need a unique name for this constraint. Check hourly pay. That's fine. Then the check within parentheses. Hourly pay is greater than or equal to $10 per hour. Okay, let's run this. Yeah, that appears to have worked. I'm going to select all from employees. Let's take a look at our table. Then we will attempt to add a new employee. Insert into employees, values. We need an employee ID, first name, last name, hourly pay, then a hire date. Employee ID will be 6. First name, Sheldon. Plankton. For hourly pay, let's attempt to pay Plankton maybe $5 per hour. Then a hire date. 2023-01-07. Let's see if that check constraint kicks in. We're paying Plankton under $10 per hour. Yeah, it doesn't appear that we can do so. Check constraint, check hourly pay is violated. Now let's pay Plankton $10 per hour. Yeah, that worked just fine. If you need to delete a check, you would type alter table, the name of the table, drop check, then the name that you gave that check. In my case, it was check hourly pay. And that check has been dropped. Yeah, everybody, that is the check constraint. It's used to limit what values can be placed in a column. It's another useful method for checking input. And that is the check constraint in MySQL. Hey everybody, in this topic I'm going to explain the default constraint. When inserting a new row, if we do not specify a value for a column, by default we can add some value that we set. Here's an example. Let's select all from our products table. Select all from products. In an earlier example, we have a table of products. A few items on the menu for sale are hamburgers, fries, soda, and ice cream. Let's add a few items on the menu that would be free. This could include napkins, straws, forks, and spoons, something you would commonly see at a fast food restaurant. If we're not using the default constraint, we would have to enter in those prices manually. So let's insert into our table products our values. Product ID 104 will be a straw. The price will be $0.00. Let's do this all together. We have 105, 106, 107. Product number 105 will be a napkin. The napkin is $0.00. 106 is a plastic fork. Again, $0.00. 107 is a plastic spoon. The price is $0.00. Then I will select all from my products table. Here's our new products table. We have our 4 items that actually cost something, then our free items, which are included with whatever we buy. In place of explicitly stating a price, one way in which we can make our lives easier, if we're adding a bunch of free items to the menu, we could set a default constraint, where if we don't explicitly set a price, the price will default to be 0, it will be free. So I'm going to undo everything that we just did. Delete from products, where product ID is greater than or equal to 104. And then we can execute that statement. If we were recreating this table with the default constraint, we would type create table, the name of the table, products in this case. At our columns, we have a product ID. The data type is integer. We have a product name. The data type is varchar, and I forgot what the size was. Looks like 25. Then a price, which is a decimal, max digit size of 4, precision of 2. Now let's use the default constraint. After the column you would like to add that constraint to, type default, then some value. I will set the default value to be $0.00. Or you could just say 0 too, that'd be fine. You would just add this constraint when creating a new table. However, I do already have a products table, so this technically wouldn't work because that table already exists. Now to alter a table to include that constraint, you would instead type alter table, the name of the table, alter the name of the column, price, set, default constraint, then the value, so 0. And that appears to have worked. Let's select our products table, select all from products. Then we will insert some new rows. Insert into products, then our values. So we had 4 rows. $104. That was a straw. $105 was a napkin. $106 was a fork. $107 is a spoon. Then finish the statement with a semicolon. So since we set that default constraint, we don't need to explicitly list the price. But we are missing one thing though. When I execute this statement, the column count doesn't match. So when we insert into products, we will list what we're inserting explicitly, the product ID and the product name. After our table name, within parentheses, type product ID, then product name. Now this should work. Yeah, and here's our products table. With our 4 inserts, all of the prices were set to 0, and we did not need to explicitly state that this time. If you don't specify a value, you'll use whatever the default is. Here's another example. I think you'll like this one. Let's say we have a table of transactions. After inserting a new transaction, we will insert a timestamp of when that transaction took place, and that timestamp will be the default. Create table transactions. At the end of this topic, we will delete this table, so don't get too attached to it. We will have 3 columns. Transaction ID, which will be of the data type integer. A transaction amount, let's just say amount. The data type will be decimal. 5 digits, precision of 2 is good. then a transaction date. The data type will be date. Actually, let's make this date time. I'd like to include the time of when this transaction happened. Now for the default constraint, after the date time, let's add default, then the now function. We don't need to explicitly add the date and time. That will be done automatically, which is kind of cool. So I'm going to create this table. Let's select all from transactions. If we're going to insert some values, we'll need at least a transaction ID and amount. The transaction date will be included automatically. So let's insert into transactions some values. Let's do one at a time. The first transaction of the day will have a transaction ID of 1, I suppose. A customer came in and bought a hamburger and a soda for a total of $4.99. Then we do need to list the transaction ID, then the amount. After our table name, add transaction ID, then amount. So let's run this. Yeah, cool. So there's our transaction ID. This was order number 1. The total amount was $4.99. And we do have a timestamp of when this transaction occurred. So the second order of the day will be for a total of $2.89. And that happened at this time. Then the third order of the day will have a total price of $8.37. Yep, there we are. So we don't need this table anymore. I'm going to drop table transactions. We will recreate this table in the future, but I'd rather start fresh. All right, everybody, that is the default constraint. When you create a table or alter a table, you can set a default value of some value you specify. Then whenever you insert a row, that value will be included automatically, which is pretty useful. But yeah, that is the default constraint in MySQL. Hey everybody, in this topic I'm going to explain the primary key constraint in MySQL. The primary key constraint can be applied to a column where each value in that column must both be unique and not null. It's typically used as a unique identifier. For example, I live in the United States. Each citizen within the United States has a unique social security number. There is a strong possibility that 2 citizens in the United States share the same first name and last name. John Smith, for example. If we're trying to find John Smith, well, which one are we referring to? We could instead search for a citizen with a unique social security number. Then we know for sure we have the right person. That's kind of the same concept with the primary key. Also, a table can only have one primary key constraint. Here's an example. Let's create a temporary table of transactions. Create table transactions. There will only be 2 columns. A transaction ID. The data type is int. I will set the transaction ID to be the primary key. There can be no duplicate transaction IDs with the same value, and none of them can be null. Then we will also have an amount. How much was each transaction for? The data type will be decimal. Max size of 5 digits, precision of 2, and that is good enough. Then I will select all from our table transactions. Here's our table. Now to add a primary key constraint to a table that already exists, this is the syntax. Alter table, the name of your table, add constraint, the name of the constraint, primary key. Within parentheses, the column we would like to apply the primary key to. Transaction ID in this example, then semicolon. However, we have already applied the primary key constraint to our transaction ID column, so this isn't going to work. But that's how you would add a primary key constraint to a table that already exists. Let's test that theory of that limit of 1 primary key per table. I'll attempt to add a primary key to our amount column. And it does not appear we can do so. Multiple primary key defined. So like I said, you can only have 1 primary key per table. And that is typically used as the identifier. Let's take a look at our transactions. Let's populate this table with a few rows. We will insert into our table transactions some values. All we need is a transaction ID and an amount. For our transaction ID, I'll just make up a number. All transactions will start in the thousands. This will be our first transaction. So the amount, a customer bought a hamburger and a soda. The total was $4.99. So let's run this. There is our first row. For the second transaction, the transaction ID will be 1001. The customer bought fries and a soda for $2.89. So that appears to have worked as well. Now the next customer buys fries and ice cream for $3.38. Let's test that theory of each transaction ID having to be unique. I'll attempt to insert this row with the same transaction ID as the previous row. Then let's see what happens. Duplicate entry 1001 for key transactions.primary. Yeah, it appears that we cannot have two rows with the same primary key. They each need to be unique. Let's change the transaction ID to 1002. That appears to have worked. Now the next transaction will be a hamburger and soda for $4.49. I will attempt to set the transaction ID to be null, which we can't do either. Column transaction ID cannot be null. Each value that's set as a primary key can't be null, and it needs to be unique. So this transaction will have a transaction ID of 1003. Two rows can share similar data. We have two customers that bought both a hamburger and a soda for the same price. But each transaction is uniquely identified by the transaction ID, which we set as the primary key. Let's say that somebody comes in to request a refund, and they give us a transaction ID. Well, we can easily look that up and refund them whatever the amount was. Select amount from transactions where transaction ID equals 1003. So we are going to refund the customer $4.99. Well, all right then, everybody. That is the primary key constraint. It's most commonly used as a unique identifier. You usually want a primary key in every table you make. Each value within a column that is set as the primary key cannot be null, and it needs to be unique. There can only be one primary key per table. Typically, it's used as a unique identifier for each row. And yeah, everybody, that is the primary key constraint in MySQL. Hey everybody, in today's topic, I'm going to explain the auto-increment attribute in MySQL. The auto-increment attribute can be applied to a column that is set as a key. Whenever we insert a new row, our primary key can be populated automatically. Then each subsequent row is auto-incremented. I'm going to recreate this table transactions, but first I need to drop it. Drop table transactions. Then we will recreate this table, but apply that auto-increment feature. Create table transactions. There were two columns, a transaction ID, the data type was int, and an amount. The data type was decimal, 5 digits, precision of 2. The auto-increment feature can only be applied to a column that is set as a key. Our transaction ID will set to be the primary key. To apply the auto-increment feature, add the keyword auto-increment. Now, by default, the primary key is going to be set to 1. So after creating this table, I will select all from transactions. Okay, we have successfully created our table. Then I will insert some values. Insert into transactions our values. So we don't need to explicitly insert a transaction ID. That'll be done for us automatically, but we still need an amount. I will insert $4.99 for the first amount. Since we're not inserting all of the values into a row explicitly, we would need to specify what column this value is for. That is for the amount. Okay, let us execute this and take a look. Yeah, so the transaction ID was set to 1, even though we did not manually insert that value. Let's insert the next amount. So we have $2.89. Yep, transaction ID 2 is $2.89. $3.38. Transaction ID 3. 499, transaction ID of 4. We could set our primary key to begin at a different value. To do that, we would type alter table, the name of the table, auto increment. Let's begin at 1000 instead of 1. Then I'm going to go ahead and drop all the rows. We'll start fresh. Delete from transactions. Select all from transactions. Okay, then let's insert those rows again and see what happens. Insert into transactions our values. 499 was the first amount. This value is for our amount column. Now this transaction ID, it begins at 1000. Then it should auto increment. The next value was 289. Our next transaction ID is 1001, 338, 1002, then 499, 1003. All right, everybody, that is the auto increment feature. It's a keyword that can be applied to a column that is set as a key. Whenever we insert a new row, our key will be incremented by 1 for each row that we insert. But yeah, that is auto increment in MySQL. Hey everybody, so in this topic, I'm going to explain what the foreign key constraint is. A foreign key, think of it as a primary key from one table that can be found within a different table. Using a foreign key, we can establish a link between two tables. There's two primary benefits to this. In my transactions table, if I were to take a look at the customer ID of who initiated this transaction, I could refer to the customers table, then find the first and last name of that customer. We can do that when we reach the topic of joins, but in this video, we're going to focus more or less on just creating foreign keys. Another benefit, when you create a foreign key constraint, that would create a link between two tables, which prevents any actions that would destroy that link between them. So here's an example. I have three tables: employees, products, and transactions. I'm going to create a new table of customers. I'm going to create this table and speed it up. Feel free to pause the video if you need to. Here's my table. We have a customer ID, which is the primary key, a first name, and a last name. Let's populate our customers table. We have three customers: Fred Fish, Larry Lobster, Bubble Bass. Each has a unique customer ID. We're going to create a link between our customers table and our transactions table via our customer ID. I'm going to drop our table transactions. Drop table transactions. We will recreate this table, but apply that foreign key constraint. So again, I'll speed up the footage. Now what I'm going to do is create a third column to hold our customer ID. And the data type is int. I would like to add a foreign key constraint to our customer ID column. On the next line, I will type foreign key, list the column we're applying this foreign key constraint to within parentheses, customer ID. References our second table, the customers table. Customers, then the column of the primary key, which was customer ID. And that's all you need to do. Then I will select all from my table, transactions. Here is our table. We have a transaction ID, this is the primary key, the amount of the transaction, then the customer ID of who initiated that transaction. Our customer ID column is the foreign key. It points to the customers table. Based on what the customer ID is, we can find the first and last name of that customer. To find any active foreign keys, go to your table, in this case transactions. Underneath foreign keys, this section will display any foreign keys that are applied to this table. We currently have one. Transactions underscore IBFK underscore 1. If you need to drop a foreign key, you would type alter table, the name of the table that has the foreign key constraint. That would be transactions, drop foreign key, then the name of this foreign key. Transactions underscore IBFK underscore 1. And that foreign key should be gone. You could also give your foreign key a unique name. Alter table, the name of the table. Add constraint, then some unique name. Let's rename that constraint as FK underscore customer ID. Foreign key, the name of the column, customer ID. References, the name of the second table, customers, then the column that has the primary key, customer ID. So to apply a foreign key to a table that already exists, this would be the syntax. You don't necessarily need to name the constraint, but if you would like to, just add that line. Add constraint, then some unique name. Let's add this foreign key constraint to a table that already exists. It worked. If I were to refresh my navigator window, we now have a foreign key, and it's the one that we gave a name to. Foreign key customer ID. What we're going to do is drop the rows from our transactions table, then reinsert them, but we will add a value for each foreign key. So let's get rid of this. Delete from transactions, then select all from transactions. Here we are. Okay, so let's insert some new rows. I do want to set auto increment to be 1,000, so I'm going to do that before we insert some rows. Alter table, transactions, auto, increment equals 1,000. So let's take a look at transactions. Then we will insert some new rows. Insert into transactions, our values. We had 4 transactions. We will need an amount and the customer ID of who initiated the transaction. The first order is for $4.99. Customer number 3 initiated this transaction. The second order is $2.89. Customer number 2 initiated that transaction. $3.38. This is also customer 3. They returned back the same day. $4.99. Customer number 1 initiated that transaction. We have our primary key from the transactions table, as well as our foreign key. Each of these customer IDs references the customer ID column from the customers table. We won't get to explore that until we reach the topic on joins. So the other benefit of a foreign key constraint is that we now have a link between our transactions table and the customers table. MySQL will prevent any actions that would destroy that link between them, unless we explicitly drop that foreign key constraint. I'm going to delete some of our customers. Delete from customers where customer ID equals 3. We were right, it doesn't appear that we can do so. Cannot delete or update a parent row. A foreign key constraint fails. So yeah, that's the foreign key constraint. It's a primary key from one table that's found also within a different table. But when we're working with that different table, we would refer to that key as a foreign key. We'll have more practice with this when we reach the topic on joins. But yeah, that is the foreign key constraint in MySQL. Hey everybody, welcome back again. In today's video, I'm going to be explaining joins in MySQL. A join is a clause that is used to combine rows from two or more tables based on a related column between them, such as a foreign key. Here's an example. I have two tables, a table of transactions and a table of customers. Think of these two tables as a Venn diagram. Transactions will be the table on the left. Customers will be the table on the right. Whatever data they have in common is the middle part of our Venn diagram. For my demonstration to make more sense, I will need to add a few extra rows. Feel free to pause the video if you need to catch up. I will insert into transactions a new row. The amount is $1. The customer ID is null. So not all transactions can have a customer ID, that foreign key. Here's a scenario. Suppose that somebody comes in, pays for a soda with cash. Well, we wouldn't have a customer ID, right? If a customer instead paid with a credit card, we could track who that customer was. There may be a customer ID who initiated that credit card charge. I'm going to insert this row, and here's our new transactions table. Not all rows have a customer ID. Then let's add one more customer. Insert into customers, first name, last name will be Poppy Puff. Let's select all of our customers. Now, not all transactions have a customer ID, and not all customers have ever initiated a transaction. They could be registered as a customer, but they have never actually bought anything yet. Using joins, let's take a look at what data these two tables have in common. We'll discuss inner joins, left joins, and right joins. Let's begin with an inner join. To create an inner join between these two tables, you would type select all from which table would you like to be on the left? Think of that Venn diagram. Our transactions table will be on the left. From transactions, inner join, whatever table you would like to be on the right. In this case, customers. On, we're going to join these two tables together by the foreign key from transactions. We'll take transactions dot the name of the foreign key column, which was customer ID, equals the table on the right dot the name of the primary key column, which was customer ID. Then we will execute this statement, and here's our new table. We have created an inner join from these two tables based solely on what they have in common. If you remember, we don't have that row for that transaction for $1 that doesn't have a customer ID. As well as our customer Poppy Puff, there's no row for her in this table. What we're telling MySQL is to select all rows from these two tables that have matching customer IDs. So that's why some data was excluded. One thing you could do with a join, this applies to left joins and right joins as well. You don't necessarily need to display every single column from both tables. You can select specific columns. Let's select our transaction ID, the amount, the first name, then the last name. This would make it a lot easier to find the first and last name of who initiated a transaction at a given time. We know who bought which order. So that is an inner join. Join together any matching rows based on some link. In this case, we're joining these two tables together by their customer ID. Now with the left join, we are going to display everything from the table on the left, but let's select all. With the left join, we will display everything from the table on the left, our transactions. However, if there is a matching customer ID, pull in any relevant data from the table on the right. Even though there's no customer ID with this latest row, we're still going to display it with a left join, but there's no data to pull in from the right table because there's no registered customer ID. With the right join, we will display the entire table on the right. If there's any matches, we will pull in any matching rows from the left. We are displaying all of our customers. If any of these customers ever initiated a transaction, we will include the data from those transactions. We still have Poppy Puff in our table, but she has no relevant transactions. She never initiated one. So yeah, everybody, those are joins. A join is used to combine rows from two or more tables based on a related column between them, such as a foreign key, like customer ID. And that is a quick introduction to joins in MySQL. Hello again, everyone. Today I will be explaining functions in MySQL. A function is a stored program that you can pass parameters into to return a value. If you look on MySQL's main website, there is a huge comprehensive list of functions. In this video, I'll only be showing you a few of the more useful ones for beginners. But just so you know, there's a lot of functions out there that do all sorts of things. What if I would like to count how many transactions took place on a certain date? To do that, we can use the count function. Select, count, parentheses. Within my set of parentheses, I can place a column, then calculate how many rows are within that column. Let's calculate amount. We will count how many rows are within the column amount. Then we will need a table. From our table, transactions. So you could add a where clause too, like where transaction date is on a certain date, but I want to keep this video as simple as possible. This function will return all of the rows within this column, amount, which is 5. We have 5 transactions within this table. Now this column header is kind of ugly. The column name is count the amount column. You could give a column an alias by adding as, then some nickname. Let's say count. It's not necessary, but if you want to make the column header look pretty or rename it as something, you could do that. Count 5. We could even rename this column as today's transactions. That works too. Do whatever you want to do. Let's find the maximum value of our column amount by using the max function. Within the set of parentheses, pass in your amount column. I will give this column an alias of maximum, and that is the maximum amount. The largest order was $4.99. There's also min to find the minimum. As minimum, the smallest order was for $1. You could do average, which is AVG, as average. The average order is $3.45. We can find the sum of a column by using the sum function as sum. The sum of all of our transactions was $17.25. For this next example, we're going to concatenate the first and last name of our employees. Select all from employees. We have 2 columns, one for a first name, the other for a last name. We're going to combine these 2 columns together with the concat function, then create a new column named full name. Here's how to do that. Select, concat, first name, last name. Then I'll add an alias as full name. Here's what we have so far. So we are concatenating the first and last names of our employees. However, we should separate each name with a space. Within our concat function, I'll add a space character surrounded with commas to separate each argument. There, that's much better. So that is the concat function. We can concatenate values together, such as if you need a column for somebody's full name. But yeah, those are just a few functions. There's still many more we haven't covered, but these are a few of the beginner ones you may be interested in. But yeah, those are functions in MySQL. Why, hello again, everybody. Guess who? It's me again. Today I will be explaining logical operators in MySQL. I would think of them as keywords that are used to combine more than one condition. For my examples to make more sense, I will add one more column, a job column. So let's alter our table of employees. Alter table employees, add column job. The data type will be varchar 25. I'll add this column after our hourly pay column. Then select all from my table employees. Here is our job column. Let's add some jobs to our employees. Let's update employees. Set job equal to, let's select Mr. Krabs, he will be a manager. Then be sure to add a where clause. Employee ID equals 1. Mr. Krabs is a manager. Squidward will be a cashier. Employee ID equals 2. SpongeBob, employee ID 3. He will be a cook. Patrick will also be a cook. Sandy will be an assistant manager. Let's abbreviate the word assistant. Assistant manager. Plankton will be a janitor. How is this related to logical operators, you're wondering? Well, using logical operators, we can check more than one condition. Suppose that our boss wants us to find any cooks that were hired before January 5th. How can we write a query that can satisfy those two conditions? Here's how. We will use the AND logical operator. Select all from our table employees. Using a where clause, we will write two conditions. Find any employees where the hire date is less than the year 2023, January 5th. So far, this would give us 3 results. Mr. Krabs, Squidward, and SpongeBob. From these 3 employees, how do we find any cooks? Well, we can add the AND logical operator. And we can write some other condition. Job is equal to cook. There, we have SpongeBob. He's a cook that was hired before January 5th. So that's the AND logical operator. You will return any results that match these 2 criteria. Another logical operator is OR. You can check more than one condition. As long as one of those conditions is true, that row will be true. Let's find any cooks or cashiers, where job is equal to cook. That gives us both SpongeBob and Patrick. They're both cooks. Or job is equal to cashier. That would also include Squidward. He's not a cook, but he is a cashier. With the OR logical operator, only one condition needs to be true, whereas with the AND logical operator, both conditions must be true. So that's the main difference between the AND as well as OR logical operators. With the NOT logical operator, NOT is a little different. NOT basically reverses anything you say. Let's find any employees that are not a manager. Where not job equals manager. We have all of our employees besides Mr. Krabs. We have cashiers, cooks, assistant managers, and janitors. You can combine logical operators too. Let's find anybody that's not a manager and not an assistant manager. Let's add and not job equals assistant manager. We have everybody besides a manager and besides an assistant manager. Mr. Krabs and Sandy are not within the results. So that is the not logical operator. It basically reverses whatever condition you write. There's also between. Between is used within a single column. It's very similar to the AND logical operator, except people prefer to use the between logical operator when working with the same column, just because of its readability. Let's find any employees where the hire date is between January 4th and January 7th, where hire date between 2 values, 2023, 01, 04, and 2023, 01-07. So we have SpongeBob, Patrick, Sandy, Sheldon. There's also the in logical operator. We can find any values that are within a set. Let's find where job is in cook, cashier, or a janitor. Yep, we have a cashier, a cook, and a janitor. There is more than one way to write a query where you need to match more than one condition. Really, the best way depends on your data set. Basically speaking, logical operators are used to check more than one condition, but they're done so in different ways depending on the logical operator that you're using. But yeah, those are logical operators in MySQL. Hello again, people. Today I'm going to be explaining wildcard characters. There are 2, the % and the underscore. Each of these is used to substitute one or more characters in a string. Here's an example. I have a table of employees. What if I need to find any employees whose first name begins with an S. Well, you would think you could write something like this, where first name is equal to S. Now, this technically doesn't work. Here what we're doing is telling MySQL to find any first names that are equal to the character S. If I instead need to find any first names that begin with the character S, I can type S, then the percent wildcard operator. The percent wildcard operator represents any number of random characters. But there's one more change we need to make still. Replace the equals operator with the like operator. Like, when used with an aware clause, searches any patterns. We will return any first names that begin with the letter S. So the results are Squidward, SpongeBob, Sandy, Sheldon. Their first names all begin with the letter S. We could do this with dates too. Let's find any hire dates in the year 2023. Technically, that would return everything in my example because all the hire dates are in 2023. We can even find if something ends with a character. Let's find any last names that end with the character R. That would return Patrick Star. Star with an R at the end. You could add more than one character. Let's find any first names that start with SP. Then change last name to first name. That would return one result, SpongeBob, SP. On the other hand, we have the underscore wildcard character. The underscore wildcard character represents one random letter. Let's find any jobs that have one random character followed by OOK. That would return any cooks. The underscore kind of reminds me of that game, Wheel of Fortune. MySQL is going to attempt to fill in any blanks with a matching character. If we had two underscores, well, there technically wouldn't be any matches. MySQL would technically be looking for a 5-letter word, where the middle 3 characters are OOK, but there's no matches. Here's another example. Find any hire dates in January. Hire date is like, the year is going to be random. We have 4 digits, 1, 2, 3, 4, a dash character, 0, 1, dash, then a day of the month. So 2 underscores. Again, that would return pretty much all of our employees. They were all hired in January. Maybe we don't care about the year or the month, but we care about the day of the month. So let's replace the month with underscores, 0, 2. That would return Mr. Krabs. 0, 3, that would be Squidward. Now you could combine these 2 different wildcards together too. Let's take a look at our jobs. Let's find any jobs where the second character is an A. I know it's kind of a weird example, but hopefully it'll make sense. Select all from employees where job is like. Now we're going to combine these 2 wild characters. The second character has to be an A. We could use the underscore for the first character, A, then any amount of random characters afterwards. That would return a manager, cashier, or janitor. So yeah, those are wildcard characters. You can use these to substitute one or more characters in a string. It's pretty helpful if you need to find if a string starts with some value or ends with some value. And those are wildcard characters in MySQL. Hey everyone, I have a super quick video on the order by clause. The order by clause sorts the results of a query in either ascending or descending order based on which column we list. Here's an example. I have a list of employees. How can I list all of these employees alphabetically? Currently they are listed by their employee ID. Well, at the end of my statement, I can add an order by clause. Order by, then a column to order our rows by. Let's order all of these employees by their last name. Now, by default, they will be ordered in ascending order or alphabetical order if you're working with characters. For descending order or reverse alphabetical order, just add DESC for descending. Now these employees are listed in reverse alphabetical order or descending order. For ascending order, that would be ASC, but that is the default. So you don't explicitly need ASC. Let's order these employees by their first name. First name. These employees are listed alphabetically by their first name. Let's do reverse alphabetical order. Yeah, there we are. Let's order these employees by their hire date. Hire date in ascending order. You don't even technically need that keyword ascending. It would still work just fine. Now descending. I think we have the hang of it now. Let's select all from transactions. There's one more thing I want to show you. Select all from transactions. We have 2 transactions with the same amount. Let's order by amount. When ordering a column, if 2 values share the same amount, we can add an additional column to compare by. Order by amount, but if 2 amounts are the same, order by maybe customer ID. These 2 rows are now flipped. So you can order by more than one column. If 2 columns share the same amount, then order by some other column. Then you can add ascending, descending, however you want to order your table. So yeah, that is the order by clause. You can order your rows by some column you specify in ascending or descending order. But yeah, that is the order by clause in MySQL. Hello, it's me again. Today I will be explaining the limit clause. The limit clause is used to limit the number of records that are queried. It's very useful if you're working with a lot of data. One use is that you can display a large data set on different pages, also known as pagination. Here's an example. I have a few customers. Not very many. I'm working with a small data set. If I would ever need to limit the amount of customers that are displayed, I can add a limit clause, then set how many I would like to display. I would like the first customer, limit 1. That would return Fred Fish in my example. If I need the first 2, that would be Fred, then Larry. 3 is Fred, Larry, Bubble. That's kind of a weird first name. And then 4 would be Poppy. Currently, these records are organized by customer ID. We could combine the limit clause with the order by clause. Let's order by last name, then limit 1. That would return Bubble Bass. It's in alphabetical order. Or we could do last name, descending, limit 1. Poppy Puff has the name in least alphabetical order, I guess. Basically speaking, limit limits the number of records that are returned. It's very useful in combination with the order by clause, which we learned about in the previous topic. Now, with the limit clause, you can add an offset. Limit 1, 1. The first number is the offset. Limit to 1 record after the first. That should technically return Larry Lobster. Yep, Larry. So limit 2 would add an offset of 2, which returns Bubble Bass. Limit 3 would return Poppy Puff. Using an offset would be very helpful when working with a large data set if you need to display your records on different pages. Suppose that our data set is maybe 100 customers. I need to display 10 customers per page. So the first 10 would be just limit 10. But, my data set's really small, so it's not going to be apparent. If I need the next set of 10 customers, I can add an offset of 10. Although I don't have that many customers to begin with. The next set of 10 customers would be an offset of 20, then display 10, then 30, 40, so on and so forth. So yeah, that's the limit clause. You will limit the results that are queried. Type limit, then some number. You could add an offset. So display some number of records after an offset. But yeah, that is the limit clause in MySQL. Hey, welcome back. Today I will be explaining the union operator. The union operator combines the results of 2 or more select statements. I have created 2 additional tables. I'm only going to be using them temporarily. I'll delete them once we're done with this example. I have a table of income. We have 2 columns, an income name and an amount. I just made up some numbers. They're probably not realistic. I also have a table of expenses. Here's my table of expenses. We have an expense name and some amount. Again, I just made up some numbers. Suppose that our boss wants us to print a list of all of our different income versus expenses, all in one window. Well, we can easily do that with the union operator. After our first select statement, delete the semicolon, add union. We now have a window with the results of these two select statements. We have income and expenses. Let's perform a similar operation with our employees and customers table. I'm going to drop these tables though, they were only temporary. Drop table income. Drop table expenses. Let's begin. Mr. Krabs, our boss, he wants us to create a list of everybody that enters the store, all employees and all customers. Well, we can join together those select statements with the union operator. But first, let's take a look at each of these tables. Select all from employees. We're going to have one problem. Our employees table has 6 columns, whereas our customers table has 3 columns. If you're combining 2 different select statements that have a different amount of columns, a union isn't going to work. We have a problem. The used select statements have a different number of columns. In order to join 2 select statements together, they need the same number of columns. My employees table has 6 columns, my customers table has 3. Well, we could select distinct columns. All I need is the first name and the last name of each of these tables. First name, last name. And look at that, that works. We have now created a list of all of the different people that enter our store, both employees and customers. There is a different variation of the union operator that is union all. That would include any duplicates if more than one value is found within each table. Just temporarily, I'm going to insert Plankton into our customers table. Insert into customers some values. Customer ID 5, first name Sheldon, last name Plankton. Select all from customers. Plankton is both in our customers table and our employees table. Now, what would happen if I add a union to those 2 select statements? With just union by itself, union doesn't allow duplicates. Sheldon Plankton is only within our list once. With union all, you would include duplicates. Now, Sheldon Plankton is in this list twice. So use whatever is more fitting for your situation. I'm going to go ahead and delete Plankton from this table of customers. All right, yeah, so that's a union, everybody. A union combines the results of 2 or more select statements. In order to do so, those 2 or more select statements need the same number of columns. But yeah, that is the union operator in MySQL. Hey everybody, today I'm going to be explaining self-joins. A self-join is really just any type of join where you join together another copy of a table to itself. They're used to compare rows of the same table. They really help with displaying a hierarchy of data. So a self-join, you just join another copy of a table to itself. So here's an example. I have a table of customers. I'm going to create another column named referred by. If a customer refers somebody and they register as a new customer, maybe they get like a free meal or something. Let's create a new column within our customers table. Alter table customers, add referral ID. The data type will be int. Then select all from customers. Now let's populate this column. Update customers, set referral ID equal to 1, where customer ID equals 2. Our first customer, Fred Fish, he was not referred by anybody. That value will be null. However, Larry Lobster was referred by Fred Fish. we'll set the referral ID for him to be 1. Larry Lobster was referred by Fred Fish. So Fred Fish gets a free meal at the Krusty Krab. Now Larry Lobster, he's going to refer both Bubble Bass and Poppy Puff. So he'll get 2 free meals. Set referral ID equal to 2, where customer ID equals 3 and 4. Fred Fish referred Larry Lobster. Larry Lobster referred Bubble Bass and Poppy Puff. It makes me think of a pyramid scheme. I'm going to use a self join to replace our referral ID column with the first and last name of the customer that referred one of these people. So I'm going to select all. Now, when using a self join, we'll take from our table customers, then inner join customers. Basically, we're just joining another copy of a table to itself, but we'll need to give these tables what's known as an alias, a nickname. Let's say from customers as maybe A, that's the nickname. Inner join customers as B. The original copy of our customers table will be referred to as A. The copy will be B. They are the exact same table, but we have 2 of them, and we'll stitch them together with a join. To link these tables by the referral ID and the customer ID, I'll add this additional line. On referral ID equals customer ID. Let's take a look to see what we have so far. Column referral ID in on clause is ambiguous. Am I referring to the referral ID of table A or table B? I'm referring to the referral ID of table A. What I'll do is prefix this column name with the name of my table, followed by dot. A.referral ID equals, I need the customer ID from my table copy, which is known as B. I will prefix B to this customer ID column. The referral ID of table A is linked to the customer ID of table B. Oh yeah, look at that. We have joined these 2 tables. The referral ID of table A is linked to the customer ID of table B. I don't necessarily need all of these columns. We're displaying everything. Let's select only specific columns. I would like a customer ID, first name, last name. Now we have one problem. With our first name and last name, do we mean the first and last name columns of table A or table B? Let's prefix these columns with the name of our table, the alias we're using. I would like the first name from table A, the last name from table A, followed by, I'm going to put this on a new line just for readability, the first name of table B, then the last name of table B. Then be sure to include that within the customer ID too. So the customer ID of table A. Okay, we're getting somewhere. Customer ID, first name, last name, first name, last name. Okay, so if somebody were looking at this table, they would think, why are there 2 columns for both first name and last name? Let's concatenate these 2 columns. Concat, first name, last name. I'll add a space in between the first name and last name. I'm going to give this column an alias. As referred by. All right, there's our table. We have all of our customers who were referred by another customer. Larry Lobster was referred by Fred Fish. Bubble Bass and Poppy Puff were both referred by Larry Lobster. You could use a different type of join besides an inner join. We could use a left join. What we're telling MySQL is to display all of our customers on the left table. If one of these customers was referred by another customer, join those rows as well. You can see that with the left join, that Fred Fish is still within our table, but he wasn't referred by anybody. That value is null. So that's one example of a self-join. We're creating another copy of the same table, then joining it together to the original, but you'll need to give each table an alias, a unique nickname. Here's another example of a self-join. Let's select all from our employees table. In our employees table, Mr. Krabs is a manager, Sandy Cheeks is an assistant manager. Let's add an additional column named Supervisor ID. To who does each of these employees report to? Squidward, SpongeBob, and Patrick, and Sheldon, they will all report to Sandy, who's an assistant manager. Sandy will report to Mr. Krabs, he's the main manager, and Mr. Krabs doesn't report to anybody. Let's add another column. alter table employees, add supervisor ID. The data type is int. And there's our new column. Update employees, set supervisor ID equal to 5. That would be Sandy. She's the assistant manager. Where employee ID equals 2. That would be Squidward. Squidward is now supervised by Sandy. 3. That's for SpongeBob. 4 is Patrick. 6 is Sheldon Plankton. Now Sandy, her supervisor ID is going to be 1. She is supervised by Mr. Krabs. Set supervisor ID equal to 1, where employee ID equals 5. And here we are. Using a self-join, we are going to display the first and last names of all of our employees, along with the full name of the person that's supervising them, because currently we only have supervisor ID. Let's utilize a self-join. First, let's select all from our table employees. We'll need to give this table an alias. As A, that's the original. Let's do an inner join. Inner join employees as B. B will be the copy. How are we going to link these? On the supervisor ID of table A equals the employee ID of table B. All right, we still have one massive table, but we can see here that Sandy appears in multiple rows, which is a good start. We don't necessarily need all of this. Let's select the first name and last name of table A.firstname, A.lastname. Then I'm going to concatenate the first and last name of table B. So concat B.firstname. I'll add a space between the first name and last name. B.lastname. I'm going to give this column an alias. That's really ugly. As reports to. That's much better. All right, we have our hierarchy of data. Squidward, SpongeBob, Patrick, and Sheldon Plankton, they all report to Sandy. Sandy, she reports to Mr. Krabs. Then Mr. Krabs doesn't report to anybody. If you would like all of your employees, even if they don't report to anybody, you could instead use a left join. Because a left join, we will display all of the rows from our table on the left. So Eugene Krabs is here, but he doesn't report to anybody. So yeah, basically speaking, that's a self-join. You can use any type of join, but the tables you use are the same one. You use the original table, then a copy of that table, but you'll need to give them an alias to distinguish them. When we're selecting the first and last names of our tables, are we referring to the original table, which I named as A, or the copy? Because that makes a difference. With self-joins, they're great if you ever need to display a hierarchy of data involving the same table. But yeah, that is a self-join in MySQL. Hey everybody, today I'm going to be explaining views. Views, they're virtual tables. They're not real. They're made up of fields and columns from one or more real tables, and they can be interacted with as if they were a real table. So here's an example. I'm going to select all from my employees table. Our boss, Mr. Krabs, he would like us to create an employee attendance sheet made up of just the first and last names of all the employees. Well, I could create a view that is made from the first and last name columns of the employees table. Now, a view isn't a real table, but it can behave as if it were. I may want to create a view of the employee first and last names instead of another table, because we try not to repeat data if we don't have to. If I had two tables, one of employees and another of employee attendance, if I need to remove an employee, I would need to do so in two places. With a view, it's always up to date. Any changes to one or more of these real tables will also update the view. So let's create a view of the first and last name of our employees table. To create a view, you would type create view, then the name of the view. Let's say employee attendance, then as. I'm going to zoom in a little bit. what would we like to select? Let's select first name, last name from a real table. Let's say from employees. So everything was successful. Let's refresh our schemas window. Underneath the views category, we have a new view, employee attendance. I'm going to select all from that view name, employee attendance. And let's see what we got. Yeah, here's our attendance sheet. We have the first and last name columns from the employees table. This view can be interacted with as if it were a real table. I will add order by last name ascending. You can use keywords and operators that we've learned about in previous lessons on a view. To drop a view, you would type drop view, the name of the view. Employee attendance. And it's gone. All right, here's another example. So views, they're always up to date, right? Let's create a view of customer emails. Select all from customers. Let's take a look to see what we have so far. I'm going to add one more column, a column of customer emails. Alter, table, customers, add column, email. Data type will be varchar. I think varchar 50 should be enough space. And there's our new column. Let's update these rows. Update customers set email equal to, the first email will be for fredfish, ffish@gmail.com. Then we'll need a where clause, where customer ID equals 1. That's our first email. Customer ID 2 will be lobster@gmail.com. 3 is bbass@gmail.com. 4 will be ppuff@gmail.com. Everybody really likes Gmail, I guess. Let's create a view from these customer emails. Create view customer emails as, what are we selecting? Let's select the email column from our customers table. Let's refresh our schemas window. Yeah, we have a customer emails view. Then I will select all from customer emails. And look at that. We have a listing of all the customer emails. And we're going to spam these people with coupons or something. I don't know. When you update one or more of the real tables in your database, those views would reflect any changes. Let's add one more customer. So let's take a look at our customers table. Select all from customers. Let's add one more customer. Insert into our customers table some values. We have 5 columns, a customer ID. First name will be Pearl. Last name is Krabs. Referral ID, let's say null. Email will be pkrabs@gmail.com. Okay, there's our new customer. Let's take a look at our view. Let's see if it updated. Select all from customer emails. Yeah, look at that. It's up to date. That is one of the benefits of a view. It will update automatically because we're using components from real tables. Any views that use that data will also be updated. The other benefit of a view is that we don't have to repeat data in a real table. Ideally, we'd only want to make a change in one place rather than across multiple tables. All right, that's a view, everybody. A view is a virtual table based on the results of an SQL statement. They're not real tables, but they can be interacted with as if they were real. The fields found within a view are fields from one or more real tables in the database. So yeah, those are views in MySQL. Yeah, it's me again, and in today's video, I need to explain what indexes are in MySQL. An index is a type of data structure. They are used to find values within a specific column more quickly. It's technically a B-tree data structure if you're familiar with what that is, but if you don't worry about it. MySQL normally performs searches sequentially through a column. If I'm looking for some specific value, just scan each value on the way down to see if those values match depending on what I'm looking for. It doesn't really take much time if you have a small data set like I do, but imagine if you have millions of transactions. Searching each transaction one by one is going to take a long time. We can speed up that process by using an index. By applying an index to a column, selecting or searching takes less time. However, updating takes a lot more time. So there's some pros and cons with using an index. It really depends on the table. If I'm working with a table of transactions, transactions are being updated all the time. People are constantly making purchases. I don't think our transactions table would be a good candidate for an index. We'll be doing a lot of updating, but not a lot of searching. However, with our customers table, I think our customers table could benefit. We don't update our customers table very often. Only a new customer comes in every once in a while. Let's reduce the time it takes to search for a customer. With creating an index, how exactly do we want to find the customer? Believe it or not, we do have an index with our customer ID already. A customer may give you their last name and or first name. Let's create an index for these. We'll start with last name though. To show the current indexes of a table, you would type show indexes from the name of the table. Here are the current indexes for our customers table. We do have one already, and that's for our customer ID. That is the primary key. We can search for a customer by their customer ID fairly quickly, but not so much by their last name or their first name. Let's apply an index to those columns. To create an index, you would type create index, then a name. I will apply an index to our last name column. I will name this index last name IDX, meaning index. On the table, customers in this case, then list a column. I will apply an index to our last name. We will be doing a lot of searching by a customer's last name, so I might as well apply an index. So let's execute the statement. Let's show our indexes again. Show indexes from customers. And here is our new index, last name index. It's applied to our column last name. If I were to search for a customer by last name, that process will be sped up now. Select all from customers where last name is equal to puff. So my data set is already very small to begin with. There's not going to be a noticeable difference in this example, but if I'm working with a million customers, using an index would be a lot faster. If I were to search by first name instead, where first name equals Poppy, I spelled Poppy wrong. Well, we don't have an index applied to our first name. As of now, it would be slower to search for a customer by their first name compared to their last name. That first name doesn't have an index. Realistically, we wouldn't search for a customer just by their first name. We would do a last name or a last name and a first name. That's where multi-column indexes come in. To create a multi-column index, you would type create index, a unique name, let's say last name, first name, IDX. On our table customers, then list the columns in order. The order is very important. MySQL has what's known as a leftmost prefix with indexes. So we will search by last name, then first name. Let's execute the statement. Show our indexes. Show indexes from customers. Here's our last name, first name index. There's a sequence. We're telling MySQL to search by a last name. However, if there's also a first name, include that too. There needs to be a last name to utilize this index. If I want to, I can get rid of this last name index, because our last name, first name index would do the same thing. We can search for a last name, as well as a first name if we would like. To drop an index, you would type alter table, the name of the table, drop index, the name of the index, last name index. Then I'm going to go ahead and show indexes from customers. And the last name index is gone. Now, if I was to search for a customer, select all from customers, where, if I were to search for a last name, we would benefit by using this multi-column index. If I looked for a last name and a first name, we would also benefit. There's a sequence. We would search through any last names first, because that's first in the sequence. But if I was to search for just a first name, we would not utilize this index. Well, everybody, that's an index. It's a type of data structure that is used to find values more quickly within a specific column. MySQL normally searches through a column sequentially. The longer the column, the more expensive the operation is going to be. If you were to apply an index to a column, searching and selecting a value takes less time, but updating that table takes longer. Use it if you think a table is a good candidate where you don't update it very often. And well, yeah, those are indexes in MySQL. Well, hello again, everybody. Today I need to explain subqueries. They can be pretty complicated, but I'll try my best to explain it simply. A subquery is just a query within another query. You write a query, enclose it within a set of parentheses. Whatever value or values are returned from the subquery, you would use within an outer query. I'll give you a few demonstrations. I have an employees table. Our manager, Mr. Krabs, he needs us to compare every employee's hourly pay with the average hourly pay of our employees table. Maybe Mr. Krabs is going to give people a pay reduction. Not an increase, a pay reduction. But he needs to compare the hourly pay of every employee versus the average. How can we write something like that? A task like that, I would say, involves at least 2 steps. We need to find the average hourly pay first, and then display every employee's first name, last name, hourly pay, then the average pay. Let's begin with the average pay. Select average function, hourly pay from my employees table. So far, so good. $15.45 is the average hourly pay of an employee. How do I use this number? Whatever value or values are returned from a subquery, we can use within a larger outer query. Let's delete this semicolon. I will surround this statement with a set of parentheses. I will then write the outer query. Let's select the first name, last name, the hourly pay, then comma, our subquery from employees. There we are. Although I'm going to give the subquery an alias as average pay. And I think I'm going to move this to the next line. That is much better. So we have accomplished our task. We have compared every employee's hourly pay versus the average. Once we complete the subquery, whatever value or values are returned from the subquery, we would use within the larger picture, the outer query. Just imagine that we replace the subquery with $15.45. This value is what was returned. Although you don't want to write a concrete number like this, just because the average pay is bound to change. Writing a subquery like this would calculate our average pay, regardless if we add or remove employees. Let's try a different example. Let's find every employee that has an hourly pay greater than the average pay. So again, we can begin with the subquery. We need the average pay. Select average function, hourly pay from employees. So again, we return $15.45. I'll use this within a where clause. Let's select the first name, last name, hourly pay from our employees table where the hourly pay is greater than our subquery. Mr. Krabs and Sandy Cheeks are both making more than the average hourly pay. What was returned was $15.45. Then it's just a matter of completing the outer query. Select the first name, last name, hourly pay from employees, where hourly pay is greater than $15.45. It looks complicated, but when you break it down into steps, it's a lot easier to visualize. we're going to cover a completely different example. We will be working with customers and transactions. I'm going to select all from my transactions table. We have a few transactions. I would like to find the first name and last name of every customer that has ever placed an order. We can do this step by step. Let's select every customer ID from transactions that's not null. Select customer ID from transactions where customer ID is not null. Let's take a look. So we do have a few repeats. We have 1, 2, 3, and 3. You can add this distinct keyword if there's any repeats. That would eliminate them. We have 3 registered customers that have placed orders in the past. Customer IDs 1, 2, and 3. But we don't know who these customers are. We will use these values within a larger outer query. I will surround this query within a set of parentheses. Eventually, we'll use this within a where clause. Let's select the first name and last name from our customers table, where customer ID, I will then use the in operator, then add my subquery. There we are. There's our 3 customers that have placed orders in the past. Fred Fish, Larry Lobster, Bubble Bass. This subquery returned the values 1, 2, and 3. Imagine that once this query resolves, we are left with the values 1, 2, 3. So this outer query makes a lot more sense. Select the first name and last name from customers where the customer ID is one of these values, 1, 2, or 3. You could do the inverse too. Find the first name and last name of every customer where the customer ID is not in the subquery. This query would return every customer that has never placed an order. Let's send them a coupon in the mail to convince them to place an order. We were left with values 1, 2, 3. Select the first name and last name from any customers where the customer ID is not in one of these values, 1, 2, or 3. Pearl Crabs had an ID of 5, Poppy Puffs was 4. So yeah, that's a subquery, everybody. It's just a query within a larger query. It helps to visualize this step by step. Imagine that we're completing the subquery first. Whatever value or values are returned, we can use within a larger query. And well, yeah, those are subqueries in MySQL. Hello everybody, today I will be explaining the group by clause. The group by clause will aggregate all rows by a specific column. It's often used with aggregate functions, such as the sum function, max, min, average, count, just to name a few. For my example, I have a table of transactions. Now if you've been following along in my video series, I did add an additional column named order date and filled in a few dates, as well as 2 additional rows. If you would like to follow along, I would recommend pausing the video, adding a new column for order date, add these order dates, then add 2 additional rows. That's all the data that we'll need in this topic. Now our boss, Mr. Krabs, he needs us to tell him how much money he made per day. What is the sum of all of the amounts per day? We have 3 different dates: January 1st, January 2nd, January 3rd. What is the sum of every amount on these days? So we can use the group by clause. That would help us. We will select the sum of every amount as a column. We will also display the order date from transactions. Then we will group by, we are grouping by our order date. Group by order date column. Yeah, look at that. There we are. Here's the sum of every amount that is grouped by these dates. Here's the total amount we made January 1st, the total amount January 2nd, the total amount January 3rd. Let's try a different function. How about the max function? What was the maximum amount on each day? These are the maximum transactions that have occurred on these dates. What about min? These are the minimum amounts grouped by order date. What's the average order every day? Here are the averages. Maybe count. How many transactions have taken place each day? We have 2 orders on the first, 2 orders on the second, 3 orders on the third. Let's try a different column. Let's group by customer ID this time. How much has each customer spent total? We will select the sum of every amount. We will also need a column for customer ID. From our table, transactions, then we will group by the customer ID column this time. Here is the sum of every amount that each customer has ever spent. We do have some rows that don't have a customer ID, so we would sum those amounts as well. So far, the customer with an ID of 3, they have spent the most amount of money at our establishment. What about the max? Here is the maximum order that each customer has placed. The min, the average, then count. Here is the amount of times that each customer has ever visited our establishment. What if we would like to use a where clause? Well, using a where clause along with the group by clause normally doesn't work. For example, I would like to display all customers that have visited more than once. Who are the repeat customers? So if I attempt to use a where clause, where count, our amount column, is greater than 1, well, we would run into an error. If you need to use a where clause, and you're using the group by clause, you would want to instead use the word having. That would do the same thing. Group by customer ID, where the customer ID has made more than one purchase. We are also aggregating all of the customer IDs that are null. Let's use the AND logical operator to remove that. And customer ID is not null. There we are. The customer that has an ID of 3, they have visited our establishment 2 times. They meet the requirements of this having clause. They have visited our establishment more than once, and their customer ID is not null. So if you ever need to use a where clause, if you're already using the group by clause, you would instead use having. So in conclusion, the group by clause will aggregate all rows by a specific column. It's often used with aggregate functions such as sum, max, min, average, count. For example, you could group by an order date. What are the total sales per date? Or by a customer ID. How many times has each customer visited our establishment? Those are just a few examples. And well, yeah, that is the group by clause in MySQL. Hey again, it's me. Today I'm going to be explaining the rollup clause, like a fruit rollup. It's an extension of the group by clause. It produces another row and shows the grand total. It's also known as a super aggregate value. Here's an example. I have a table of transactions. What I would like to do is to group each transaction by the order date, then produce a grand total. Here's what we'll do. I'll give you a few different examples. Let's begin by selecting the sum of the amounts and the order date from our table transactions. Then we will group by the order date. And there we are. We have the sum of every amount per order date. Using this rollup clause, I can add an additional row that shows a grand total, so to say. All I have to do after the group by clause is add with rollup. And there you go. Here's the grand total. 7.88 plus 8.37 plus 8.97 is $25.22. Here's another example. Let's count the transaction IDs by order date. We have 2 transactions on the first, 2 on the second, 3 on the third, for a total of 7 transactions. I'll give you 2 more examples. Let's select the count of our transaction IDs per customer. I'm going to give this count an alias as number of orders. as well as the customer ID column. From our table, transactions, we will group by customer ID. Let's see what we have so far. Then I will add with rollup. Here are the amount of orders per customer ID. The customer with an ID of 3 has visited here more than once. The grand total of the number of orders is 7. That's the rollup. One last example. Let's select our employees table. Select all from employees. We will group all of these employees by their employee ID, then display a rollup of all of the hourly pay. As a business, how much are we spending on all of our employees per hour? So let's select the sum of our hourly pay. I'll give this an alias as hourly pay. I guess it really isn't different from the column name. We will display the employee ID as a column. From our table, employees, group by the employee ID with rollup. Here's the hourly pay of each employee, as well as a grand total. If all of our employees are working currently, we are spending, as a business, $92.75 per hour. Well, yeah, that's the rollup clause, everybody. It's an extension of the group by clause. It produces another row and shows, essentially, the grand total. It's also known as a super aggregate value. To include a rollup after the group by clause, just add with rollup. It's probably good for accounting. And well, yeah, that's the rollup clause in MySQL. Why, hello there everybody. Today I will be explaining the onDelete clause. There's two versions, onDelete set null and onDelete cascade. With onDelete set null, when a foreign key is deleted, we can replace the foreign key with the value null. Otherwise, there's onDelete cascade. When a foreign key is deleted, delete the entire row. Here's an example. Let's take a look at our table transactions. Select all from transactions. In my transactions table, the customer ID column is the foreign key. What would happen if I were to delete one of these customers? Let's select all from our customers table. I'm going to delete Poppy Puff. She has a customer ID of 4. Delete from customers where customer ID equals 4. If you run into this error, cannot delete or update a parent row, a foreign key constraint fails. There's a foreign key that's preventing us from deleting this customer, because this customer is used elsewhere in a different table, like that transactions table. So just temporarily for this demonstration, I'm going to set foreign key checks to be 0. And that should work. Our customer with an ID of 4 is gone. 1, 2, 3, 5. Poppy Puff is no longer within our customers table. Before I forget, I'm going to set foreign key checks back to 1. Let's take a look at our transactions table. Underneath this transaction of 1005, we're referencing a customer that doesn't exist. The customer with an ID of 4 is no longer within our customers table. We have a couple options whenever we delete a primary key from another table that's being used as a foreign key somewhere else. We can either replace that value with null or delete the entire row with cascade. With onDelete set null, we can replace this value with null, much like these two rows. Or onDelete cascade, we can delete the entire row. Let's begin with onDelete set null. I'm going to reinsert Poppy Puff back into our table of customers. And there we are. Poppy Puff is back in the customers table. Now with onDelete set null, if we're creating a new table, let's say I'm recreating my table of transactions. After adding the foreign key constraint, foreign key, our customer ID column, references the customer ID column of the customers table. I can add this clause, onDelete set null. That's if I'm creating a new table, but I already do have a transactions table. I don't want to update it. However, we can update an existing table with this clause. I already do have a foreign key constraint. I'm just going to drop it real quick. Alter table, transactions, drop foreign key, then the name of the foreign key. Mine is fk underscore customer ID. And that key is now dropped. We are going to add a foreign key constraint to our transactions table with this clause on delete set null. Alter table, the name of the table, add constraint. You can give your constraint a name. I'll give it the same name as before. fk customer ID, list the foreign key, my foreign key is customer ID, references another table, which was customers, and what is the primary key of that table? Customer ID. Then we will add the clause on delete set null. If I delete a customer ID from customers, the foreign key of that row will be set to null automatically. Let's execute this. Let's take a look at our transactions table. Select all from transactions. I am now going to delete customer number 4 from the customers table. Delete from customers where customer ID equals 4. Yeah, check that out. With our transaction ID of 1005, the customer ID is now null. Now there's onDelete cascade. When a foreign key is deleted, we can instead delete the entire row. Let's go ahead and add Poppy Puff back to our customers table. All right, she's back in. Let's drop the current foreign key constraint of our transactions table. Alter table transactions, drop foreign key fk customer ID, or whatever else it's named. And that key is now gone. We will add the onDelete cascade clause to a table that already exists. Alter table transactions, add constraint. You can come up with the name fk underscore transactions underscore ID, list the foreign key customer ID, references the customers table, and the primary key of that table is the customer ID. Then add on delete cascade. Let's take a look at our transactions table. Select all from transactions. Oh, let's update this customer ID real quick. I forgot to do that. Update transactions, set customer ID equal to 4, where transaction ID equals 1005. Yeah, I forgot to add that back. Now let's do it. Delete from customers where customer ID equals 4. Yeah, take a look at that. The entire row is now gone. We have transactions 1003, 1004, 1006. 1005 is missing because it was referencing the customer with an ID of 4. We set the foreign key to delete the entire row when that foreign key is deleted. That is onDelete cascade. Well, in conclusion, everybody, onDelete is a clause where if you delete a foreign key, you can set that value to be null, or cascade, which will delete the entire row, which has its uses. And well, yeah, that's the onDelete clause in MySQL. Why, hello again, it's me. So today I gotta explain stored procedures. A stored procedure is prepared SQL code that you can save. It's great if there's a query that you write often. For example, I have this statement. It's very verbose, there's a lot we have to write. If this statement is something I have to write often, I could save it and reuse it later. This statement will interjoin the transactions table and my customers table then display all customers that made a transaction. This statement is very verbose. If I have to write this statement often, I could save it as a stored procedure. I can refer to the nickname that I gave that snippet of code. The name I gave this procedure was get customers. Then I need to call this stored procedure. And that does the same thing, and it's a lot less to write. There's also a few other benefits, which we'll discuss at the end of the video. Let's begin with something simple. I would like to select all from my customers table. To turn this statement or statements into a stored procedure, I will type create procedure, then a name for the statement or statements. I will name this statement get customers. Add a set of parentheses, type the keyword begin. Wherever your statement or statements end, type end. Then for clarity, I'm going to tab all of my statements between begin and end. So we have a problem. We're trying to create this procedure. However, MySQL is stopping at this semicolon here. We end all statements with a semicolon rather than at the end. Our semicolon is known as a delimiter. It's kind of like the period at the end of a sentence. We're telling MySQL that our statement ends here, but we need our statement to end here after the end keyword. We can actually change the delimiter temporarily. Type delimiter before we create the procedure. Typically, when people change their delimiter temporarily, they'll either use 2 forward slashes or 2 dollar signs. I'll stick with the dollar signs because I think that's cooler. After we create our procedure, let's change our delimiter back to the semicolon. MySQL no longer recognizes our semicolon as the delimiter. After the end keyword, I will use our new delimiter to end the statement. That should work now. Let's execute the statement. We have created our procedure. I'm going to refresh my navigator window. Underneath stored procedures, we have our stored procedure of get customers. To invoke the stored procedure, type call, the name of the procedure, get customers, add a set of parentheses, then a semicolon. That will execute whatever code you stored within your stored procedure. To drop a stored procedure, you would type drop procedure, the name of the procedure, get customers. Let's try another example. This time, we will send our procedure a piece of data within the set of parentheses, a customer ID number such as 1, 2, 3, 4, so on and so forth. We will get a customer by their customer ID. We will create a procedure. I will name this procedure find customer. Add a set of parentheses. To find a customer by their customer ID, when we invoke the stored procedure, within the set of parentheses, we will need to place a customer ID. But when we create the stored procedure, we have to set up what is called a parameter. We will type in, then a nickname for that piece of data. We're passing in a transaction ID. I'll give this parameter a nickname of ID. Then we need the data type of what we're passing in. We're passing in an integer. So we have one parameter set up. Let's use that begin keyword, that end keyword, list our statement or statements between these two keywords. I will select all from my customers table where my customer ID equals the ID that we pass in, that nickname. We need to change the delimiter because MySQL thinks we're trying to end our statement here, but we need it to end after the end keyword. So let's change the delimiter to double dollar signs, then change it back. All right, we have created that stored procedure. Let's invoke it. Call find customer. Within the set of parentheses, we need to pass in a customer ID number. Let's pass in 1. That would give us Fred Fish. 2 is Larry Lobster. 3 is Bubble Bass. 5 is Pearl Crabs. When you invoke a stored procedure, you can pass in some data, depending on what you need exactly for your stored procedure. Let's drop this procedure, then do one last example. Drop procedure, find customer. This time we will send two arguments, two pieces of data, a first name and a last name. Create procedure find customer. Within our set of parentheses, the first piece of data we'll pass in will be a first name. But first is already a keyword, maybe F name, meaning first name. Then the data type. Let's see. For customers, the data type of first and last names is varchar 50. Varchar 50. For your next piece of data, you would separate that with a comma. In, our nickname will be lname for last name. Data type is varchar 50. Then I'm just going to put that on a new line for clarity. Type the begin keyword, and write your statements between begin and end. We will select all from our customers table, where first name equals the name of the data that we pass in, and last name equals the other piece of data, the second piece, the last name. Again, we need to change the delimiter to create this procedure. Double dollar signs. Then change it back. We have created our stored procedure. Let's invoke it. Call find customer. Within the set of parentheses, we will list a first name and a last name. Larry, comma, Lobster. Get Larry Lobster's information. Let's find him. And there he is. Customer ID 2, first name Larry, last name Lobster, referral ID of 1, email is llobster@gmail.com. All right, everybody, that is a stored procedure. It's prepared SQL code that you can save. It's great if there's a query that you write often. A few of the benefits is that it reduces network traffic, it increases performance, and is more secure. An administrator can grant permission to a user or an application to use a stored procedure. One of the downsides, though, is that it increases memory usage of every connection. And well, everybody, those are stored procedures in MySQL. Hey everybody, today I need to explain triggers. When an event happens, a trigger does something. I know that sounds very generic. For example, when we insert, update, or delete a record, we can use a trigger to check data, handle errors, or audit tables. We can do a plethora of things. Here's an example. I have a table of employees. We have an hourly pay column. Maybe I would like a salary column. Whenever we add an employee or update our hourly pay, the employee's salary will be changed automatically with the trigger. Before creating a trigger, let's update our employees table. We'll add a salary column. Alter table employees, add column salary. The data type will be decimal, 10 digits, precision of 2. We will place this column after the hourly pay column. Then select all from our employees table. Let's see what we have. There we are. There's our salary column. Let's update our employees table. Set our salary column equal to the hourly pay times. To calculate an employee's salary using an hourly pay, Sheldon Plankton, for example, take the hourly pay, $10 per hour. There's typically 40 hours in a work week, then 52 weeks in a year. Plankton would have a salary of $20,800. So a shortcut, you could just take the hourly pay times 2,080. There are 2,080 work hours in a typical year. So take the hourly pay times 2,080. Then we will select all from employees. There is everybody's salary currently. Whenever we update an employee's hourly pay, I would like to also update the salary automatically with the trigger. I don't want to have to calculate every employee's salary manually, using a calculator like I just did. We're going to create a trigger. Create trigger. Then we need a name for this trigger. Before we update the hourly pay, we're going to do something. I will name this trigger before hourly pay update. We'll use either the keyword before or after. Do you want to do something before or after? I would like to do something before. Before what? Before an insert, before a delete, before an update. Before an update in this case. On our table, employees. Then add this line, for each row. We may be working with more than one row using a trigger, so that's why we're including this line. This trigger can involve one or more rows. Now, what are we going to do before we update an employee's hourly pay? Let's set the salary equal to the hourly pay times 2080, because there's 2080 work hours in a typical year. Okay, there's one more thing I'm going to add. Let's prefix salary and hourly pay with this new keyword, new.salary, new.hourly pay. MySQL doesn't know if we're referring to the old salary and the old hourly pay. We're telling MySQL we're calculating a new salary. Use the new hourly pay when that's changed in place of the old one. Okay, let's take a look. Let's execute this statement. Our trigger has been created. In your schemas window, to find any triggers, go to tables, then find that table where we applied the trigger, employees, then triggers. I probably need to refresh this. There it is, before hourly pay update. Otherwise, you can type show triggers. And here is our trigger. Here's the trigger name, event update, the table, the statement, and the timing. Let's select all from employees. Mr. Krabs is going to give himself an hourly pay raise because he's greedy. Let's update our employees table. Set the hourly pay equal to $50 per hour, where our employee ID equals 1. So Mr. Krabs' salary is about $53,000 per year. Before we update it, we will change the salary of this employee from $53,000 to over six figures, $104,000. That change happened automatically with the trigger. Before updating the employee's hourly pay, we calculated a new salary automatically. Let's make another change. Let's increase every employee's hourly pay by $1 per hour. Mr. Krabs is now feeling generous. Update employees, we will set the hourly pay equal to whatever the hourly pay currently is, plus 1. We will apply this for every employee. We don't need a where clause. There, everybody is now making $1 more per hour, and the salaries reflect that. Let's create a new trigger. We will calculate a salary whenever we insert a new employee. More specifically, whenever we insert a new hourly pay. Right now, we have a trigger that only kicks in when we update an hourly pay. Okay, let's delete Plankton. Plankton got fired. Delete from employees, where employee ID equals 6. Select all from employees. There, Plankton is now gone. Let's create a trigger. Create trigger before hourly pay insert. Are we doing something after or before? We're doing something before an event. Before, are we updating, inserting, or deleting? We are inserting. Before we insert a new record on our table, employees, for each row, let's set the new salary equal to the new hourly pay times 2080. Here is our new trigger. Let's take a look at our employees table. Select all from employees. Let's insert a new employee. Insert into employees, values. I'm just going to follow these columns. Employee ID 6. First name is Sheldon. Last name Plankton. Hourly pay is $10 per hour. For the salary, I'm going to set this to null. Our trigger will kick in and set that. Position, janitor. Hire date, 2023, January 7th. Supervisor ID of 5. Let's see if our salary is calculated. It was. Plankton's hourly pay is $10 per hour, meaning he has a salary of $20,800 per year. I do have a few more examples. Triggers are something you'll want to master. They're really helpful. We're going to create a new table this time. Create table expenses. Our expenses table will have 3 columns. An expense ID. The data type will be int. This will be the primary key. You could set this column to auto increment if you want, but that's overkill for this topic, I would say. I'm going to try and keep it simple. Expense name. The data type is varchar. 50 is good, I suppose. Then expense total. I will set that to be decimal. 10 digits, precision of 2 is fine. Then let's select everything from our table. Expenses. Let's insert some values. Insert into expenses. We have 3 rows. 1, 2, 3. ID of 1. The expense name is salaries. For the value, for now, I'm going to set that to be 0. The second row will be 2. Supplies, 0. ID of 3. Maybe taxes. And 0. I will calculate the expense total of my salaries row. Update expenses. I will set the expense total equal to, I'll use a nested query. Select the sum of salary from employees, where our expense name column right here is equal to salaries. This is all of the salaries combined from the employees table. The total is $254,280. Whenever we delete an employee, we will update this value found within another table, our expenses table. So let's create a trigger. Create trigger after salary delete. Are we doing something before or after? We're doing something after deleting a salary. After delete on employees. For each row, we will update our expenses table and set the expense total equal to whatever the expense total currently is, minus that employee's salary. If we're deleting a salary, we will refer to that salary as the old salary. Then add a where clause. Where expense name equals salaries. Okay, we have created our trigger. Let's take a look at our expenses table. I'm going to delete Plankton again. He's fired. Delete from employees. where employee ID equals 6, that's Plankton. Then select all from expenses. Look at that, our expense total changed. It's now $233,000. Let's create a trigger that will update our salaries whenever we insert a new employee. Create trigger after salary insert. We're doing something after this time. After and insert on our table employees. For each row, we will update our expenses table. We will set the expense total equal to the expense total plus the employee's new salary, new dot salary, where expense name equals salaries. Let's insert a new employee. Let's take a look at our expenses table, select all from expenses. We will insert a new employee, insert into employees, our values, employee ID 6, first name is Sheldon, last name Plankton, hourly pay of $10 per hour. The salary will be null. That will be calculated automatically with the trigger. Position is janitor. Hire date 2023-01-07. And a supervisor ID of 5. Let's see if this expense total will change. Which it does. When we insert a new employee, more specifically a salary, our expense total of salaries will be updated. One last example, then I promise we're done. Let's create a trigger that will update this value when we change an employee's salary, and that will probably be the most complicated one. Let's create a trigger after salary update. We're doing something after we update on our table employees. For each row, let's update expenses, set the expense total equal to the expense total plus the employee's new salary minus the employee's old salary. What's the difference? We'll find the difference between the employee's new salary and their old salary, add that to the expense total, where expense name equals salaries. We have created our trigger. Let's select all from expenses. Mr. Krabs is going to give himself another pay raise. Update employees, set the hourly pay of Mr. Krabs to $100 per hour, where employee ID equals 1. Our expense total underneath salaries is now changed. It's now $356,200. Well, all right, everybody, that's a trigger. In simple words, when an event happens, do something, such as when we insert, update, or delete something from a table. A few of the benefits is that you can check data, handle errors, and audit tables. It's a really helpful tool to have. And well, everybody, those are triggers in MySQL.